Hello and welcome, strange people of the internet. I am Kiara Blows. I am a biomedical sciences student at Newcastle University, and I'm going to be your physical sciences tutor with Tutor Box Live in conjunction with COVID-19 catch-up courses. So I hope you are as excited as I am to get our think on. This lockdown is just, you need to engage your mind. Right, we know that. So I know a lot of people are very intimidated by physical sciences, and it is said to be the most difficult subject, maybe. And it definitely does have its difficulties, but I think you just have to know what to look out for, tips and tricks, which I will definitely share with you. And who knows, maybe you'll get the marks you've always wanted, which I believe in you, 100%. And so I just wanted to I'm so proud of you for taking the time out of your day to sit here and listen to what I have to say, because I'm not a very interesting person, but I can help you with science, so we'll go with that. And yeah, so grab your notebook, probably your worksheet that you were sent with us, some writing materials, your willpower and your brain, and perhaps a very caffeinated beverage, and let's get started. So welcome back to your second lesson. We are going to be doing chemistry, and more specifically, organic chemistry. Organic chemistry is the chemistry of carbon compounds in living and non-living systems. So therefore, organic molecules are molecules that contain carbon. So carbon is what makes something organic. The organic compounds that you guys study in high school and stuff will consist of carbon, hydrogen, oxygen, and halogens, which are often represented as an X instead of all the BRCLI. Catenation is the formation of long chains of carbon atoms. So that's just when you add more carbon to carbon. Very fancy, I know. When organic compounds contain only carbon and hydrogen, they are called hydrocarbons. Very, very complicated, I know. So carbon is always surrounded by exactly 4 bonds, and that makes sense because of its valency of 4. Similarly, oxygen is always surrounded by exactly 2 because it only has 2 spaces, and hydrogen is always attached to exactly 1 bond, and halogen is also exactly attached to 1 bond. So just think of your periodic table when it comes to this and how many electron spaces, if you will, you have spare, so like your Lewis diagrams. Okay, so more definitions. Unsaturated and saturated are 2 very important distinguishing features of organic chemistry. So saturated are compounds in which there are no multiple bonds between carbons. So these are single bonds only. Unsaturated are compounds with 1 or more multiple bonds. So this can be a double bond or a triple bond, and they can have more than 1. A functional group is a bond, an atom, or a group of atoms that determine the physical and chemical properties of a group. So this just distinguishes them and allows them to be categorized. There are different ways of representing molecules. So you can have your molecular formula, your structural formula, condensed structural, 3D structural formula, which is not too important at the moment, and skeletal formulas. So in a structural formula, all the bonds in the compound are shown. If these bonds are omitted, it is called condensed. So here is an example of the molecular formula. So that is the formula for that specific molecule. So we've got C2H6. Your structural formula will show every single bond. So this is almost like your Cooper notation. So we've got 6 H's, 2 C's, and they're all bonded by singles. Then the condensed structural formula will be CH3, CH3. So it's not as simple as your molecular where all the C's are together and all the H's are together. It does kind of show you how the structure is. It's just a bit simpler than your structural. And then your 3D shows if it's coming out of the page or into the page. It's not too commonly dealt with at this level just because they are difficult to draw and it is difficult to know. And then finally, your skeletal formula is drawn like that, where you don't have anything, and each point will represent like a carbon. Alright everyone, so here it's just a little quick YouTube video showing you the formula of organic molecules. So this is just going to discuss your chemical formula, drawing formulas, empirical, structural, all that type of stuff. Just in a more visual way, so you can hopefully consolidate all this information and won't have to look back at it again. It's a nice little video. I hope you enjoy it. And if before exams, you want to procrastinate but do something productive, have a watch of this video.
In this video, you will learn how to use different types of formula to represent organic molecules. The formula used most frequently in our videos has been the displayed formula. This is because displayed formula provides the clearest visual structure of an organic molecule. Here is the molecule butene, showed in displayed formula. It shows all the atoms in the correct order with lines to represent all single and double covalent bonds. Drawing all the bonds for very common molecules can be quite repetitive. For example, here is butanoic acid in its displayed formula. Since this is a common molecule, and as chemists we are clear with the bonding arrangement of carboxylic acid functional group, we also use structural formula to represent organic molecules. Here is the structural formula. As you can see, the covalent bond between the OH is not showing, as we know this arrangement anyway. In fact, we could simplify this further and remove all the displayed bonds like this. Structural formula is often used when writing equations, but the formula doesn't mean that it's always clear what arrangement bonds are in. Here is another example. First, the displayed formula of propane. If we then take out the lines representing the covalent bonds and group our atoms together in order they are arranged, we make the structural formula of propane. Pause the video now and try and draw both the displayed formula and structural formula of pentane, which has 5 carbon atoms. Here is the displayed formula of pentane, and here is its structural formula. Molecular formula is another type used and shows us only the number of each type of atom in the compound. To work out the molecular formula, you simply add up each type of atom. For example, here is the displayed formula of hexane. As you can see, it has 6 carbon atoms and it has 14 hydrogen atoms. The molecular formula of hexane is therefore C6H14. This alone is not very useful, as it does not show us how the atoms are arranged and where the bonds are. If you look at these molecules, they all have 6 carbon atoms and 14 hydrogen atoms. Although you may not be able to name these different molecules, you can see they are very different, but all have the same molecular formula. This is the molecule glucose. Pause the video now and complete the molecular formula for glucose. You should have counted 6 carbon atoms, 12 hydrogen and 6 oxygen atoms, so the molecular formula is C6H12O6. Sometimes the formula is reduced even further to make an empirical formula. The empirical formula is the simplest whole number ratio of atoms in a compound. We need to find the highest common factor, that being the largest whole number that is a factor of 6, 12 and 6 in this example of glucose. They all divide by 6. And so if we do this, we get C1H2O1. We don't show the ones, and so the empirical formula is CH2O. Although empirical formula doesn't show us the molecule or how it is arranged, it does tell us the ratio of atoms in the molecule. Now, at the end of this video, you should understand how to draw organic molecules in displayed, structural, molecular, and empirical formula.
Okay, so the next definition we're going to do is talk about your homologous series. So this is a series of compounds, molecules, that have the same general formula and the same functional group. So remember, the functional group is what sets it apart, and each member of the homologous series differs from the previous member by a CH2 group. So for example, we've got the alkanes, which are single covalent bonds, and they're saturated. And their general formula is CnH2n plus 2. So we've got butane here, which has 4C. So you would put your 4 in there to get your 4C, and then you'd work out 2 times 4 is 8, plus 2 is 10, and you'd have H. 10 hydrogens, which you will see 3, 6, 7, 8, 9, 10. Alkenes, however, have one or more double bond. This is unsaturated, remember. Their formula is CnH2n, as you've seen by this one. Okay, so I've only got 2, 4, 5, 6, 7, 8 bonds instead of an extra 2, which makes sense when you think about what the double bond does. Alkynes, however, have one or more triple bonds. So their general formula is CnH2n minus 2, and you can see that because they only have 6. Okay, because you've taken away lots of bonding opportunities, and this is also unsaturated. Other homologous series and functional groups and all of that, this table does summarize it pretty nicely so you know what you're dealing with. Different schools, so like IB or DBE, will require you to learn different ones, and it does change slightly over the years, but this is an overall one and you just need to learn what you need to know. Generally, you will have to know the first 3. It's the second 2 that fluctuate whether you know, but they're here in case you need to know them. So alcohols are defined by their OH or hydroxyl functional group, and their name always ends in ol. So I'm going to stick with butanol. Okay, your carboxylic acids are compounds that have a carboxyl functional group, and that's your COOH, and they end in oic acid. So butanoic acid, tongue twister. Esters are compounds that have a CO and a COO bond. Okay, this is a reaction between a carboxylic acid and an alcohol, and that forms your ester. So the first part will come from your alcohol, and the second part will come back from your carboxylic acid. Then we have your ketones, which have a carbonyl group, and that's just a C with a double O, which is found in the middle. So as you can see, it's kind of just degressed. And their suffix is 1. Aldehydes also have a carbonyl group, but I think it's at the end, not in the middle, and they have an ul. And then I just have this slide up. Just as a summary, I'm just talking about what we've spoken about into one page. I do encourage you as much as possible to simplify organic chemistry for yourself and to just put it in a way where you can compare and contrast and just get everything in your head correctly. So we've got the homologous series: alkynes, alkenes, alkynes, haloalkanes, alcohols, aldehydes, ketones, carboxylic acids, and esters. So those we've all covered. And we know the hydrocarbons are only these 3 because these have your oxygens or hydrogens or your halogens. This is your formula column for your general formula. We've got the functional group: single bond, double bond, triple bond, halogen. Alcohols have the OH. Aldehydes have your CO carbonyl group. Your ketones also have a carbonyl group, and your carboxylic acids have your carboxyl group, so your COOH, and your esters have your COO. Okay. All right, and then we've given the suffixes, which is just how you tell the difference. Example names. And then here we have structural formula. So remember that your aldehydes and your ketones both have a carbonyl group, so it's just positioning. As you can see, that's towards the end, and that's very much in the middle. Alrighty, and then we've got the condensed structural formula, which is just that. written in order, and then adding all those up, you get your molecular formula. So this is just a nice table to condense everything. This is some examples that I would like you to answer, and then I will go through which ones are correct. So just attempt these for a few minutes on your own. Alright, so I hope you had a chance to attempt the quick multiple choice. Shouldn't have taken you too long, probably like 2 minutes or so. Alright, so I'm going to go through each of the questions just so you know the right answers and why they are the right answers. So for the first one, the general formula for alkenes, remember, is 2n minus 2. And so your answer would be B. Remember, because it's got a triple bond, it takes away almost 3 types of chances of bonding and stuff like that. Just think of it like that, and then the minus will make more sense. Okay, then the complete combustion of octane. So this one would be a little tricky. You do know octane obviously is octane is a C8H20. 8 times 2 is 16, right? Yeah, so actually that would be 18. Yeah, 18 plus O2. So that would give you CO2H2O, but this would just be more of like a little outside the box thinking. Then, which one of the following reactants can be used to prepare this ester? So remember, the first name comes from the alcohol, so we know it's going to be ethanol. The second part comes from the carboxylic acid, so that's going to be methanoic acid, so that's going to be C. Okay, so the reason A and D should immediately have been eliminated are because they are hydrocarbons, which don't make up at all. So as long as you got between B and C, you probably would have gone like half marks, but as long as you know that the alcohol always comes first. Okay, then the last one does not contain a carbonyl group. So remember, carbonyl is CO. So what are the functional groups of each? So remember, your carboxylic acids have your carboxyl group, and your aldehydes and your ketones have your carbonyl group. So that's your aldehydes and carboxylic acids out the way. And then remember, your alcohol only has OH, so that does not have a C in it, a CO carbonyl group in it. And esters, remember, are your alcohol and a carboxylic acid, so they will have a carbonyl group in them. Okay, so I hope you had a nice break, and we're going to jump into it to part 2. And enjoy! So part 2 is going to be dealing with naming of organic compounds. So remember, it has to be named according to the International Union of Pure and Applied Chemistry, or IUPAC for short. So there's 3 components. You've got your prefix, this is the position and names of side chains listed alphabetically. You've got your root, the number of carbon atoms in the main carbon chain, and your suffix is determined by the homologous series. So step 1, you need to identify the functional group, and then that will tell you the homologous series. So in this case, we've got a double bond, so we know that it is an alkene. Then, find the longest chain of carbon atoms, and it must include the functional group, and it doesn't need to be in a straight line. So find as many carbon atoms in a row as you can. It doesn't have to be a straight row, but just leaning on from one another. And then you number the carbons in this chain from the side nearest to the functional group. Okay, if there's an alkane or haloalkane, you will start numbering nearest to the side chain. Okay, this is just how you will name it. So if there's 1, it'll be meth, 2 eth, 3 prop, and so on. Pretty straightforward. If you cannot remember the first 4, because the rest from there are pentagon, hexagon, octagon, you all know those. You can remember monkeys eat peanut butter. That's just the little mnemonic I used to use. And then at least while you're still getting the hang of it, before you know, it might be a little quick shorthand. Okay, so we're going to indicate the position of the functional group. Okay, which is basically what has been summarized in here. Alrighty, next we're going to determine whether are there any substituents. So this is your side chains and stuff. So we're going to count the number of carbon atoms to determine the prefix and end it on YL. So this, for example, only has 1 carbon, so it'll be your methyl. And then you do have to reference which carbon this is attached to. So for example, here you'll have 2-methyl because it's attached to the 2 carbon. And you're going to separate the number and the name with a hyphen. If it occurs more than once, however, so for example, if there are 2 in here, and there's 1 pointing that side, you can say it'll be a di, and so on. Tri means 3, 4 means tetra. So we can say, even if they're not on the same one, you can also say 3, 4 dimethyl. Okay, and if there's more than one substituent, you can write their names and positions in alphabetical order. Next, naming the compound with a substituent in front of the parent chain. So remember, we've got 2-methyl first, then we've got our root, which is prop, we've got the position, which is 1, and then we've got the ene. You can move the 1 in front there, so you can say 2-methyl 1-propene, or you can put the 1 in between. It is up to you. Okay, if the hydrogen is removed from the alkyne, the group of atoms which remains is called an alkyl group. So this is just explaining the side chains a little bit further. They're named by replacing the ane with a YL. Okay, and they're written in front. Your side chain's always written in front. So you got your methyl, ethyl, propyl, and butyl. And then you number the carbons in the chain starting from the end, which is closest to the branch, which is what we've said. Just emphasizing the important parts. And then remember, if your hydrogen is replaced by a halogen, so an alkane, you have bromo, chloro, fluoro, and iodo. Actually, could be an alkene or an alkyne as well. Okay, so just another note, when naming haloalkanes, the halogen atoms do not get preference. Okay, so the numbering should start from the side near to the first substitute. Okay. So it doesn't matter, neither of them get preference. And then obviously you have to, if there are more than one halogen, you have to do it by alphabetical order. So the substitutes appear as prefixes written alphabetically, but the prefixes di and tri should not be used to determine the alphabetical order. So remember, this just tells you the amounts, but the actual substitutes will be written in alphabetical order. And in molecules where the functional group is always on the first carbon, such as carboxylic acid, aldehydes, there is no number added to indicate the position. So ethanoic acid or pentanol. Okay, just little tips to remember. Okay, so we are going to go through actually naming these. Exciting. I just wanted to point out that number 5 is the same as number 6. All right, so we're going to go through the answers now. So, firstly, we look for the functional group. So we've got a triple bond over there. So that tells you it's an alkyne. Okay, so we start numbering with the closest one. So you can either start there or there. It's the same. We're going to go 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that tells you it's going to be octyne. And then you know that's going to be 3-octyne or oct-3-ine. And then we know that it's a methyl group on the 2. So your answer is 2-methyl oct-3-ine. Okay, next one. We know that that is your alcohol. So we've got 1, 2, 3, 4. So butanol, and it's 2-butanol or butan-2-ol. Okay, then we're going to skip to this one. So we've got a CCOO. And remember I told you that that was an indication of an ester. Okay, so remember that an ester is made up of an alcohol and a carboxylic acid, and your alcohol is always first. Your alcohol is also the one that is the closest to the O, whereas your carboxylic acid is the one closest to the double O. Okay, so therefore that will be methyl, so that comes from methanol. And then you go 1, 2, 3, 4, so that's going to be butanoate. Okay. Okay, so for number 7, we've got a bromo, we've got a methyl, and we've got another methyl. So remember, it doesn't matter where you start this, basically. It's just the one closest to either. So we're going to start here. So we're going to 1, 2, 3. So it's 1 brom, 2.2 dimethyl, and propane. Okay. And then for this last little bit, I am going to go through these multiple choice questions with you and then give you a few questions to do on your own. Okay, so which one represents an alkane? So what is the general formula? Try think back. Remember, it is CnH2n plus 2. So we know it's not that one, and we know it's not that one. Okay, so if you've got C3, we know it's going to be H8, so our answer is D. An organic compound has the structural formula shown below. The correct name for the compound is, So we notice that, so we know it's going to be an ene, an alkene. So we start numbering them. 1, 2, 3, or 1, 2, 3, however. And you know that it's therefore a methyl group, okay? However, you don't have to have any numbering to this, so we'll have methyl propene, because if you move that C there, it will then become butene. So there's no other way to put it, so you don't have to have any numbers. Okay, the next one. The structural formula of an organic compound is given below. So we're going to start closest to our structural alkene bit. As you can see, all of them have an ene. So we're going to go 1, 2, 3, 4, 5, 6, 7. Okay, so we know that that is going to be on the 2. So it's either B or C. Okay, 2 ene. Hept is 7, which is why 1, 2, 3, 4, 5, 6, 7. And we know that it's dimethyl because there's 2 methyl groups. That's 7, that's 6, and that's 5. So therefore it's 5.6 dimethyl. So it is B. Okay, and then this is adapted from a paper 2 question, and I would like you to attempt these. Alrighty, so you had an attempt at these questions and hopefully they were okay. I know there were a few that we haven't really covered on and we'll go into in further detail later on, but hopefully just getting the gist of it for now will be okay. Alright, so write down the letter that represents a ketone. So remember, a ketone is a carbonyl group that's in the middle. So that would be D. Okay. A compound which is an isomer of prop 1-ene. So we haven't dealt with isomers as yet, so you could have skipped that one. And I'm just going to give you my answer, and then next time we can revisit it. So it is C. And if you think about it, it is kind of similar because it's only one with 3, and it's 3 that doesn't have any other functional groups, so that works. Then write the formal name for compound A. So remember, okay. We're gonna add from the right. 1, 2, 3, 4, 5. So that's pent. And since it's got a CO, we know it's L. So pentanol will be at the end of our sentence. Now we've got to work out the front bit. So we go 1, 2, 3, 4, and that is where our methyl group is. So it's for methyl pentanol. Okay, compound B. So we start on the left this time, and we go 1, 2, 3. So it's propene because it's got a triple bond. You can put a 1 in, although there's no other way to write it. It'll always be 1. Okay. Next one, two products form with the complete combustion of E, which will be H2O and CO2. So this is what I touched on earlier. Remember, whenever you take an alkane and you put it in oxygen, so you combust it, you'll get H2O and CO2, or water and carbon dioxide. Alrighty, next one. The name of the homologous series to which compound F belongs. Ethyl butanate. Remember, it's got two parts to its name, so it belongs to the esters. The structural formula of the functional group of carboxylic acids. So you would write your C, and then you would have coming out of it a double bonded to an O and an O and an H. Okay. And 2.4.3, the name of the carboxylic acid from which it's compared. So remember, alcohol first, carboxylic acid next, so it's butanoic acid. The structural formula of compound F will be, I'll screenshot it here, and you just have to highlight the structural formula. And then this is from a real paper, so just to show you how they would break it down. Alright, but other than that, we are officially done with your part 2 of physics. Just to reiterate, I am Kiara Blows. If you go away and just feel a bit more confident understanding the concepts, and that you're engaged as much as possible. That's all we can ask of you. There will be a Q&A session, and I think there is another session after this. So please tune in again soon. It was lovely to meet all of you, and I hope to be teaching you all again soon. Enjoy your day, stay safe, stay hydrated, and stay active. Bye.
It's not a matter of whether or not we can. Everybody can, but not everybody will. How to turn nothing into something. How tangible are ideas and imagination? Ideas that become so powerful in your mind and your consciousness, they seem real to you even before they become tangible. Imagination that is so strong that you can actually see it. You can actually see it. If somebody cannot see it when it is not here, then it will never be here. Start looking into the future of what you would like to accomplish, where you would like to go, the person you would like to be. Decide what you want, and then act as if you already had it. And that is to believe that what you imagine is possible for you. So the first step is to imagine what's possible. Second step, to believe. Now here's the third step, and that is to go to work and make it real. You now go to work and make it a movement. You make it tangible. You make it viable. You breathe life into it, and then you construct it.
You have a lot to offer. The fact that you're still here means that your business is not through yet. People don't do what they know in life, but what they do is they operate within the context of the vision they have of themselves.
So write and draw and build and play and dance and live as only you can. Make up your own rules. The rules on what is possible and impossible were made by people who had not tested the bounds of the possible by going beyond them.
You must change what's possible for you. You, and only you, are the subject that impacts the burning desire in your imagination. You are living and feeling as if your future dreams are a present fact.
Will it be easy? No. Will it be challenging? Yes.
So you got to prepare yourself. You've got to develop yourself. As long as you're breathing, you got some more work to do. There's something else for you to achieve. Guess what? You're going to make some mistakes. You're going to make a lot of mistakes.
So now go and make interesting mistakes, make amazing mistakes, make glorious and fantastic mistakes, break rules, leave the world more interesting for your being here. Make good art.
It is possible to start with nothing and become something.